another case study from the chapters Quadrilaterals, because as I can see this word, this says after summer vacations, Chinmay's class teacher organized a small MCQ quiz based on the properties of quadrilaterals. So this is for class 9 quadrilaterals. It says during the quiz, she asked different questions to students. Some of the questions are listed below. Which of the following are the conditions for ABCD to be a quadrilateral? I suppose यही होगा यहाँ पर लिखा हुआ ABCD to be a quadrilateral. Yes, this is a quadrilateral. So there's all 4 points ABCD must be distinct and coplanar. Coplanar, that means they lie on the same plane. And distinct, of course, they should be distinct points. No three of them are collinear. Yes, they should not be on the same line. Otherwise, no quadrilateral will be formed. Line segments AB, BC, CD, DA intersect at their endpoints only. Obviously, no, the line segments do not intersect like this. So they intersect at their endpoints only. So here, hence my answer would be all 4 of them. All of these would be the conditions to form a quadrilateral. So which of the following is wrong condition for quadrilateral said to be a parallelogram? So when a quadrilateral becomes a parallelogram, so what are the properties of parallelogram it says, and which of the following is a wrong condition, right? Opposite sides are equal. Opposite sides are equal in case of a parallelogram. This is true. And opposite angles are equal, obviously. Opposite angles are also equal. It says diagonals can't bisect each other. Now, if we see a parallelogram, the important condition that we use in case of a parallelogram is that because of the lines being parallel, the opposite lines being parallel and equal, we say the diagonals bisect each other. Right, so the diagonals bisect each other. So which of the following is a wrong condition? C part is the right answer, that diagonals need to bisect each other. The diagonals will bisect each other. Diagonals bisect each other in parallelograms. This is an important property of parallelograms we'll use in class 10th as well. Next it says AX and CY are bisectors of angle A and angle C of parallelogram ABCD, right? This is the bisector of angle A and this is the bisector of angle C. And we also know that angle A and angle C are equal. They are opposite angles of a parallelogram. Then they say which of the following is true? AX is parallel to CY. This is true. AX is parallel to CD. AX is parallel to CD. We can see these are intersecting lines. How can this be true? AX is parallel to AB. Again, intersecting lines. How can it be parallel? So because we know that when we've taken the bisectors of angles, half of angles are equal, right? So we just need to prove, I will say that they are bisectors of angles like this, that we know that AB is parallel to CD, right? And we also know that AY is parallel to CX. AY is parallel to CX. And if I say angle A is equal to angle C, they are opposite angles of parallelogram, right? In the same way, half of angle A is equal to half of angle C. So I can say angle YCX is equal to angle YAX. YAX. These two are equal angles because halves of equals are equals. And because AB is parallel to CD, we know that AB is parallel to CD and AX is transversal. If we take AX is transversal, can I say angle YAX is equal to angle AXD? They are alternate interior angles. So from here, from this and this, so I conclude that angle YCX is equal to angle AXD. YCX equal to angle AXD. Now as you see, the two form pair of corresponding angles. So we write as these form a pair of corresponding angles. So hence we conclude that Hence, we conclude that AX is parallel to CY. So I've proven this also. AX is parallel to CY. I'll mark the first part as the answer. AX is parallel to CY. Let's come to the fourth part now, which says ABCD and AEFG. These two are parallelograms. Angle C is given as 63 degrees. Then determine the value of angle F hota hai is case mein. I know this question. It would be to find the value of angle F. So now because ABCD is a parallelogram, opposite angles are equal. So angle C would be equal to angle A. So I can say angle A is 63 degrees. Again, AEFG is a parallelogram, opposite angles are equal, so angle F will also be equal to 63 degrees. You can tell me the question if this statement is missing, but the actual question from in other books and other forms always asks us to find the value of angle B. So here I would say angle F is also equal to 60 degrees. From here, angle C is given as 63, opposite angles of parallelogram, so angle A is 63, and AEFG is also a parallelogram. So angle F opposite to angle A would also give me 63 as the right answer. So I'll mark my answer 63 in this case. And the last one says if the angles of a quadrilateral are in the ratio 3 is to 5 is to 5 is to 7, find all the angles. So I'll say let the angles be 3x, 5x, 5x, 7x, and by angle sum property of quadrilaterals. Angle sum property. Sum of all angles of quadrilateral is 360 degrees. So we add all angles 3x plus 5x plus 5x plus 7x. So 8, 13, 20. 20x is equal to 360 degrees. X will be equal to 360 divided by 20, which will give me 18 degrees. So therefore the angles are 3 into 18, 5 into 18, 5 into 18 and 7 into 18. 3 into 18, 54 degrees, 5 into 18, 90, and then again 90, and then 7 into 18 would give me 126 degrees. So here my answer in order would be 54, 90, 90, 126. Just as an extension, if we draw the quadrilateral and mark these angles, what can we say about that quadrilateral? So I randomly take any quadrilateral, right? And in which I get two angles as 90. So I'm drawing this quadrilateral with this intention that two angles are 90. So in order I take this is 54, this is 90 degree, this again is 90 degree, and this is 126 degrees. So if you add these two pairs, these two, the sum is 180 degrees. And if we add these two pairs, again the sum is 180 degree. So here a better question would be, what type of quadrilateral? What type of quadrilateral? What type of quadrilateral is this? So based on the angles, what we can say? I can only conclude that these two sides are parallel because co-interior angles are supplementary. So based on this two angle sum, which is 180 degree in both the cases, I can say the given quadrilateral is a trapezium. So another question which can add to this question would be that if the ratio of angles is given as 3 is to 5 is to 5 is to 7, I can find the type of quadrilateral. The type of quadrilateral in this case would be a trapezium.